Webb's first real image of another world was only the beginning. What came next was even more astonishing: a giant planet glowing in the darkness, an ocean world candidate wrapped in hydrogen, a scorching planet with exotic chemistry unfolding high in its atmosphere, a nearby world we can detect but still cannot truly see, and a planetary system once believed to be filled with possible Earth-like worlds that may actually be far harsher than anyone imagined. This is what the James Webb Space Telescope has begun to reveal. Not a single extraordinary planet, but a pattern. The galaxy is filled with countless worlds, yet every time we examine them more closely, they become less familiar. The stakes could hardly be higher because Webb is transforming the search for life from speculation into evidence. On K2-18b, Webb detected methane and carbon dioxide while also reporting a possible signal of dimethyl sulfide, DMS, although NASA emphasized that this potential detection still requires further confirmation. On WASP-39b, Webb produced an extraordinarily detailed chemical profile of an exoplanet's atmosphere, revealing signs of photochemistry and demonstrating that alien skies can be far more complex than scientists once expected. Meanwhile, observations of the TRAPPIST-1 system have shown just how difficult true habitability may be, narrowing or ruling out several atmospheric possibilities for nearby rocky planets. The question is no longer simply whether other worlds exist. Instead, scientists are asking how many of those worlds might actually be alive. For decades, other worlds remained almost invisible, not because they did not exist, but because they were everywhere. Thousands of planets orbit stars throughout the galaxy, including gas giants, rocky planets, frozen worlds, scorching worlds, planets larger than Jupiter, and others that may resemble Earth. Yet almost none of them were seen directly. Instead, astronomers found them through indirect clues. A star dimmed slightly. A star wobbled under an unseen gravitational pull. A repeating pattern appeared in the starlight. These subtle signs proved that the planets were real, but the worlds themselves remained hidden. Scientists could estimate a planet's size, calculate its orbit, and infer some of its properties, but they could not simply point to an image and say, "There it is," as they can with Mars, Jupiter, or Saturn. That changed when the James Webb Space Telescope observed HIP 65426b. At first glance, the image does not appear especially dramatic. It is not a blue Earth-like world covered with clouds, oceans, continents, storms, or cities. Instead, it appears as a tiny point of light. Yet that tiny point marks the beginning of an entirely new era because it is not a star, it is a real planet orbiting another sun. Webb captured HIP 65426b using infrared light rather than visible light. Infrared reveals heat, making it possible to detect young, hot planets that would otherwise be overwhelmed by the brilliance of their host stars. Imaging such a world is incredibly difficult. The star is overwhelmingly bright while the planet is astonishingly faint, much like trying to photograph a firefly beside a stadium floodlight from thousands of miles away. To accomplish this, Webb had to block the star's light, eliminate its glare, and carefully search the surrounding darkness until the faint glow of the hidden planet finally emerged. HIP 65426b is a massive world several times larger than Jupiter. It is young, intensely hot, and orbits far from its parent star, glowing softly in infrared light. Yet this remarkable image immediately raised new questions. The planet exists much farther from its star than simple models of planetary formation would predict. Did it form in that distant location? Was it born closer to the star before being pushed outward? Did another giant planet scatter it into its present orbit? Was its early planetary system violent, chaotic, and unstable? The image did far more than prove that Webb could photograph another world. It demonstrated that seeing a planet is only the beginning. Once astronomers can see it, they must also explain how it came to be there. That is what makes Webb's first direct image of an exoplanet so significant. It does not provide all the answers. Instead, it opens a door. Beyond that door lies an entire galaxy filled with planets behaving in ways scientists never expected. Some are far hotter than predicted. Others are far larger. Some orbit dangerously close to their stars, while others appear to possess atmospheres that should not have survived. Among them may even be worlds covered by deep global oceans beneath skies unlike anything found on Earth. One such world is K2-18b. This is where Webb's discoveries become even more intriguing. HIP 65426b demonstrated that Webb could directly reveal a distant exoplanet, but K2-18b introduced a far bigger question. Could Webb eventually reveal evidence of life beyond Earth? K2-18b looks nothing like our planet. That is the first thing to understand. It is larger, heavier, and far stranger than Earth. Orbiting a red dwarf star approximately 120 light-years away in the constellation Leo, it spent years as just another promising exoplanet among thousands of known candidates. Interesting, certainly, but not revolutionary. Everything changed when Webb examined its atmosphere. Suddenly, K2-18b became one of the most intensely debated planets in modern astronomy. Webb was not taking a conventional photograph. Instead, it used a technique known as transmission spectroscopy. As K2-18b passed in front of its star, a tiny fraction of the starlight filtered through the planet's atmosphere. That light carried chemical fingerprints because different molecules absorb specific wavelengths before the light reaches the telescope. By studying those missing wavelengths, Webb could determine which gases were present in the atmosphere. The results were remarkable. Webb identified methane and carbon dioxide while finding little evidence of strong ammonia signatures. These observations are not isolated facts. Together, they support the possibility that K2-18b could belong to a class of planets known as Hycean worlds, planets with hydrogen-rich atmospheres covering vast global oceans beneath. Imagine not another Earth, but a darker, larger, and heavier world, wrapped in a thick blanket of hydrogen gas with an immense ocean stretching beneath it for thousands of miles.